My name is Renee Clark, and this lecture is over Chapter 8 of the Think Python ebook. Strings are not like integers, floats, or booleans. A string is a sequence, and it's an ordered collection of other values. It is a sequence of characters, and you can access each character one at a time using the bracket operator. Here we have an example. Fruit is set equal to coconut, a string. We're going to look at a letter. So we're going to use fruit, setting letter equal to fruit inside of square brackets 1, and then we're going to display. And we get an O. Expression in the brackets is called an index, and the index indicates which character in the sequence you want, hence the name, index. Here we're going to pull out 5, and we get a U. Why is it that when we said 1, we got an O, when we said 5, we got a U? Well, you have to think about how a computer scientist counts. We start counting from 0. So in order to see the first letter in the string, we have to use the 0 to call it. So it's a 0 index. Here we go. We've got the example of where we're pulling out the very first using index 0, and it shows it is a C for coconut. That means if you count the number of letters using a typical counting method in a string, it's going to be one higher than its index. Now we can find out how long it is, how many characters are in there, using the built-in function len. So it's just going to return the length. And you can see that when fruit is set to lime, it gives a length of 4. There are 4 characters there. So you might try to access that 4th character using the length, but that doesn't work because the string length is out of the index, because remember, the index starts at 0. So in order to prevent that from happening, we can get it by subtracting 1. See, inside of our square brackets, we call the length on fruit, but we also subtract 1, and that gets us the last character. In this case, it's set currently to lime. Another way, we can use negative indexing. Negative indexing is used. -1 is the last character, the E for lime. And -2 would be the second to last, and so on, depending on the size of your text string. Sometimes you want to make computations on one character in a string at a time and just kind of go through from beginning to end. This is called a traversal. Let's look at an example using a while loop. Here we have fruit set to kiwi. We have the index starting at 0. So while index is less than the length of the fruit, then we want to print out that letter. And then we're going to increment our index. We get kiwi printed out one letter at a time. Here's another simple way to write it. We could do it using the for loop. Same result. You can also do concatenation using strings. Remember, we can concatenate strings, and we use the addition plus sign in order to do that. Here we will create the ducks' names using concatenation. So we know that our book has Jack, Cack, Lack, etc., right, all the way through Quack. And we're going to put the first initial, or the first letter of the string, all in prefixes. We're going to add the ack as a suffix. So we're going to say for letters and prefixes, print the letter plus the suffix. Each letter, so first it's going to pick up J and add it to there, and so on. And we see it's doing exactly what we asked. However, it's not right because up here the O and the Q require a U. So we have to do something additional. How do we fix that? An easy fix is inside of our for loop, we add an if statement. And we say if letter is equal to O or letter is equal to Q, then print letter plus U as a string, single string, plus the suffix. Otherwise, just the suffix in the letter. And you can see now we are getting the O and the Q with the U. Some important things to remember, of course, is how does indexing work? It starts at 0. Counting in Python starts at 0. So when you're looking for an index, and if you want the first character, the index is 0, not 1. We can also slice our strings. We do this by using indexes that include a colon. In this example, we have 0:9. The 0 is the nth character, meaning the start of the slice. And here it's going to be inclusive. The 9 is the end of the slice, and it is excluded. So in this example, we would be picking up characters 0 through 8 because 9 is excluded. And in this example with Henderson, it will get us just the word Henderson without the blank space. If I want just the last word, I'm going to go not to 9, I'm going to go to 10 through 17, and it will get me the rest of the string, which in this case is readies, but it doesn't bring out the blank. We can omit the first index before the colon, and that slice will start at the beginning of the string. If we omit the second index, the slice goes to the end of the string. So here we have a couple of examples. We have fruit equal to peach, and if we say square bracket :3, we're going to get 0, 1, 2. We're not getting number 3. Remember, it's excluded. Let's see if I'm right. Yeah, so we get PEA. Here we want from number 3 through the end. And remember, P is 0, E is 1, A is 2, C is 3, H is 4, so we should just get C and H here. Other important things to remember about strings: they are immutable, meaning they cannot be changed. So you can't use the square brackets, that index operator, to change characters in a string. So if I tried to change this from hello students to Jello students, what happens? I get a type error because the string is immutable and I cannot do that. I can create a new string that includes part of an original string, however, using indexing. So I could say, make a new string that substitutes the J for the H in hello students. So we're creating a variation. So here we're doing that. We have our greeting, hello students. We're going to create a new greeting. We're setting it equal to J, the string J, plus greetings, the original greeting, from index 1, so that's going to be the second letter in the string, to the end of the string. And that gets us Jello students. Keep those kind of things in mind. When I create a new one, it has no impact on the original string. Now, another useful thing we can do with strings is we can search. And that's what this following function does. So we can call the function find, send it a word, and send it a letter. So I send a word in a string, I send a string with a single letter, and it will look and see if it finds that letter in the word. If it does, it will return the index for that letter to me. And if it doesn't find it on the first, when it goes in at 0, it will increment it and keep looking. Once it finds it, it returns that index. If it never finds it, if that letter is not in the word, it returns a -1. Instead of using the square bracket operator, you can use find, which is kind of the inverse of that, and you can find out the index for a letter in a word. We can also do some looping and counting with string. So the program here counts the number of times the letter I appears in a string. So we give it the word Mississippi, and it should find the letter I, tell us how many times it shows up, and then print that count out for us. And it shows us that the I appears 4 times in Mississippi, and in fact it does. So how did that code work? Well, we have a string assigned to word. We set a counter to 0, and then we start our for loop. And we say for every letter in word, remember 4 lets us look at each individual in this string. If it's equal to an I, it adds count plus 1 to the count. Once it finishes the for loop, it's gone through the entire word, it then just prints the results. We also have some string methods that are very helpful, and these are the dot notation type of methods. So we can use them. Here they're demonstrating the upper. So you have a string, in this case ready, that's been assigned to word. You can create a new word that will have ready appear in all uppercase. So when we run this code, we get readies in all uppercase. Now, this form of dot notation specifies the name of the method, upper, and the name of the string. You don't need to pass a parameter. There are no arguments, so you put the empty parentheses at the end. And the method call in this fashion is called an invocation. We also have the in operator that works with strings. And in is a Boolean operator. It takes 2 strings and returns true if the first appears as a substring in the second. So here we've got E in ready. That returns true because there is in fact an E in ready. What about F? Are there any F's in ready? False. No, they're not. Now you can also use that functionality in this fashion. Here we're creating a function that prints all the letters from word 1 that also appear in word 2. So let's look at this. So we have a function definition in both, and we pass 2 parameters, word 1 and 2. For each letter in word, we're going to look and see if it's in word 2. And if it is, we print the letter. So let's set that function up, and now let's call that function. We're going to pass Henderson and readies are 2 strings. And we find out that those 2 words share an E, a D, an E, and an S. Again, useful functions that you can find uses for as we go through our programming examples throughout the semester. We also have a string comparison. The relational operators work on strings, so we can compare and see if word is equal to banana. And if it is, print out all right bananas. Right now, word has been set to apple. Let's see what we get. We get no output, okay, because they're not equal. You can also use these relational operators for putting words in alphabetical order. So here we've set word to zebra, and we say if word is less than banana, then you're going to print it here. This way your word, give your word, comes before banana. If it's greater than banana, your word comes after banana. And if they don't meet either of those, they must be equal, so you say, all right, bananas. So which do you think we will get from this? We should get your word zebra comes after banana. Now, a thing to keep in mind when you're alphabetizing, words that are capitalized are always going to come first. So let's see what happens if we run this with a capital Z. Your word zebra comes before bananas now because zebra is a capital letter. It's started by a capital letter. If you have any questions regarding this material, contact your professor.